Hi students, welcome to my YouTube channel SADHIK Physics, where you can learn physics very easily. Right? If you are the first time, if you are seeing, please go through my past videos, no, how easily I taught all different topics. So today's topic, no, we'll discuss from the ray optics, no, that is refraction and up to the total internal reflection now, and we'll go for different applications now, and different model questions also we will discuss in this video now, right? So if you are first time, please subscribe to my channel now. So now let us see, there are some different questions now which are involved in this one now, right? So I think it is visible, no? If it is not visible also, so don't worry. So try to understand what I am explaining on this. Clear? So angle of light ray is incident on a glass surface of refractive index is √2 from air at an angle of incidence is 45 degree. Find out angle of refraction. So simple question, no? Simple, right? So this is your glass, right? This is your air. Refractive index is 1, refractive index is √2, keep in mind. So now therefore here light ray is incident. What is this angle of incidence? No, angle of incidence is 45 degree. So he is asking angle of refraction. No? So very simple one now. Apply the Snell's law here. So what is the Snell's law? You have to travel from here. So 1 into sine 45, it will be equal to, so entering into this one, no, refractive index of this one is √2 into sine r. Clear? So what you will get it now here. So sine 45 is 1 by √2. So therefore √2 into sine r. So taken here, no, sine r, it will be equal to, so 1 by 2, therefore sine 30. So angle of refraction is nothing but a 30 degree. Now light ray is entering from, so therefore denser medium to rarer medium, angle of deviation is nothing but a I minus r. I is how much now? 45 minus 30. So therefore 15 degree will be your angle of deviation. You understand? No? Very simple one, no? Right? Now let us go for one more concept, no? Right. Right. A light ray is moving from air to denser medium of a refractive index is mu. It is observed that angle of refraction is half of the angle of incidence. Find the angle of incidence. Very good. So same type of question, no? Therefore here this is refractive index is mu. This is for air. Air means 1. Now light ray, what happened now? It is traveling from air to denser medium, no? So this is your angle of incidence, no? Here he said that angle of refraction. So this angle of refraction is nothing but a I by 2. So he is asking angle of incidence, right? So now again apply the Snell's law here, no? So Snell's law you can apply here, no? What is the Snell's law? You are traveling from here. 1 into sine I is equals to sine I is equals to mu into sine of r, that is nothing but a I by 2. Clear? So sine I, sine 2 theta can be written as 2 sine I by 2 into cos I by 2 is equals to mu into sine of I by 2. This will cancel out onto this, right? So here 2 taken now, cos I by 2 is equals to mu by 2. So cos inverse I is equals to I by 2. Therefore 2 into cos inverse of mu by 2 will be your angle of incidence. Clear? So just trigonometry concept onto this. Clear? In this way you can solve these problems, no? Now, right. So find this. Okay, this is one more question, no? Is it visible? Right. Find the speed of the light in medium B. There is a medium B. If the speed of the light in medium A is c by 2, where c is the speed of the light in vacuum. Light refracts from medium A to medium B, making an angle of 45 degree and 30 degrees respectively to the normal. So first of all, A, B, something it is there, no? Just let us first analysis onto this. Therefore, right. Find the speed of the light in medium B if the speed of the light in medium A is c by 2. Light refracts from medium A to B. Therefore, this is A, this is B. Clear? So now light ray is traveling like this. Clear? Now this he gave the speed of the light speed of the light in this one now c by 2. Therefore, here we want to calculate the speed here now. Clear? So it is making an angle of incidence 45 degree. This angle of refraction is 30 degree. Clear? So again you can apply the Snell's law here now. So very simple one now. Apply the Snell's law here now. So therefore refractive index of A and refractive index of the B. So therefore absolute refractive index of A into sin 45, it will be equal to absolute refractive index of the B into sin 30. Clear? Clear? So refractive index of A is nothing but a speed of the light into speed of the light in A into sin 45 is 1 by root 2. So therefore speed of the light in air by speed of the light in B is nothing but a 1 by 2. Clear? So therefore this C cancel here no. So therefore speed of the light in medium B is equals to this taken here no. So 1 by root 2. Root 2 by 2 means 1 by root 2 into speed of the light in A. Speed of the light in A is nothing but how much no? It will be is c by 2. Therefore 1 by root 2 into c by 2. C by 2 is nothing but 3 into 10 to the power of 8 by 2. So speed of the light in B can be written as 3 by 2 root 2 into 10 to the power of 8 meters per second. This is here the speed of the light. You understood no? Clear? Now we will go for one more question now. Right. Find out the total angle of deviation after two refractions now through the glass sphere of refractive index is root 3. Here it is air, here it is air, here it is root 3. Right. So total deviation means what you will get it now. Again, if you did not see my video in reflection through the plane mirror, no, total angle of deviation you can rewrite it as angle of deviation 1 plus angle of deviation 2. You have to use proper sign onto this, right? So if you did not see, please see this one. No? You have to follow the sign conventions, clockwise and anti-clockwise, like that. Clear? So now first let us see what will happen now. Here it is entering from rarer to denser. What will happen now? Bend toward the normal. Bend toward the normal. Then it will go like this. Clear? So here, right? Now this light ray, now it is entering like this. Now it is entering from denser medium to rarer medium, it will bending away from the normal now. This is your refracted ray, this is your emergent ray. Clear? So now we will see what will be this angle here now. This angle we want to calculate. Apply the Snell's law here now. Then apply the Snell's law here. So then calculate angle of deviation at this point. First point we'll calculate this is your first point and this is your second point. Clear? So now first one now, what you can write it now? Apply the Snell's law. Entering from this one now, 1 into sine 60 is equals to root 3 into sine r. This is your r. Clear? Sine 60 is nothing but a root 3 by 2 is equals to root 3 into sine r. So this root 3 cancel now. Therefore sine r is nothing but a sine 30. So therefore here angle of refraction is nothing but a 30 degree. Clear? So what will be your first angle of deviation now? Therefore, so I minus r. So therefore it will be equal to 60 minus 30. So therefore it will be 30 degree. So it will be in the clockwise. What is the clockwise now? See. So actually this light ray should go like this. This much amount of getting deviated now. This is delta 1. That is, it is rotating like this. So it is in the form of like this. That's why it is written as like a clockwise. Understood? Clear? Now here, so this is already a normal onto this one. No? Therefore this also it is making an angle of refraction, that is nothing but a 30 degree. Now what you can write it now? Here second one, no? So we can rewrite it as second one. So again apply the Snell's law here, no? So here r, therefore root 3 into sine 30, it will be equal to, so this is your angle of emergence, no? 1 into sine e. Clear? Right? So sine 30, therefore 3 by 2, it will be equal to sine e. So that is nothing but a sine 60. So therefore here e value will be equal to 60 degree. Clear? So what will be the angle of deviation second one now? So therefore emergent angle of this emergent ray, actually this is now, this like this should go, but what happened now? This much amount of getting deviated on this. Clear? Sorry, this is your incident ray. So this is your incident ray, this much is getting deviated now. Angle r, so 60 minus 30, therefore 30 degree clockwise. Now what will be your total deviation now? Total net deviation. So this is 130 and 30 degree clockwise plus 30 degree clockwise, totally 60 degree clockwise will be your answer on this. Clear? In this way you can do these questions, no? Here. Now we will see one more question here now. Right. Find out the apparent distance between the bird and fish seen by the bird. Also we can add one more question, no? Find out the apparent distance between the bird and fish seen by the fish. Okay. So we can add one more question, no? Therefore here seen by the bird, second question, no? Seen by fish. So that you can get still more clarity onto this. Clear? First, seen by the bird. Bird is seeing. Seeing is which one now? Rarer medium is there. That means we are standing outside and so we are seeing the object inside onto this one. So that means what will be the shift here now? First question. This is your first question, no? And this is your second question. First question, what you can write it now? So this object is inside the denser medium, but we are seeing, that means we are standing outside the water and we are seeing into the fish inside this one. That means object is there inside the fish now. Therefore this fish now, it looks like somewhere here. Clear? This fish looks like, I mean for this one, no, it is somewhere here. This we can call it, this is apparent depth now, this is we can call it as like a shift onto this. Clear? Apparent depth. What is apparent depth now? So what you can write it now? This distance is 36 centimeters seen by the bird. So distance d is equals to 36 centimeter plus apparent depth. 36 centimeter. Apparent depth can be written as like a real depth by apparent depth can be written as like a real depth by it is n. Real depth is how much now? 24 divided by, so refractive index is how much now? 4 by 3. This is 4 by 3 means will go down, right? So this is how much now? This is 6 times 18. Therefore, it will looks like 18 centimeter, no? How much it will be now? 40, 50, so 54 centimeter. For the bird, therefore the fish looks like it about 54 centimeters onto this. Clear? But for the fish now, that means we are seeing no, right. So we will see. So this one now, this is the fish, right? This fish is about 24 centimeter no. This bird is there no, bird is there. This at 36 centimeter. Now this object is at in the air, so therefore it is looks like very far away onto this. Therefore, this it will be your from here to here we can call it as like a apparent height. What is the apparent height now? Therefore, apparent height can be written as like a n into h. Clear? So therefore n into h. So what is this n now? N is nothing but a 4 by 3. So n is equals to 1 here now. Therefore 4 by 3 into h. H is nothing but a 36. So therefore it will be 12. So therefore 48 centimeters. That means for the fish it looks like height about 48 centimeter. So therefore distance now, distance which was looked by the fish now, fish is already at a distance of 24 centimeter plus apparent height. What is this apparent height now? 24 plus 48. So this is 60 and 72 centimeter. Clear? So in this way, apparent depth, real depth, no, you should be very clear onto this. Then only can able to solve the problems after this. Clear? Now let us go for one more question. No? Find out the value of h, this h now, right? Such that light rays retrace its path after reflection. So light rays retrace its path after reflection means what should happen now? Therefore, here this from here to here it should be the center of curvature onto this for this type of mirror onto this, right? Clear? Now this object is at this point, no? Therefore, so this distance should be equal to mu times of h, no? So therefore here, because object is in the sun, no? Therefore we are able to see it, right? So light rays are coming and falling on this. Therefore here these are coming and falling, undergoes like a refraction, no? Then it should fall onto this one, no? Center of curvature onto this center of curvature, then it will be get reflected back onto this. Clear? So this height should be equal to, so mu times of your h. You understand, no? Therefore here you can read it as, so total radius of curvature should be equal to, therefore here mu times of h, from here this is here plus h now. So therefore here mu times of your h is equals to r minus h. So mu is equals to r minus h by h. So this should be your mu value. Sorry, h value we want to calculate. H is equals to by mu. Clear? Now we will see. Yeah, this is one of your NEET question. So, right, we will see an air bubble is there inside the cubical block of glass of side 4.5 centimeters, seem to be at 2 centimeter from one face and 1 centimeter from other face, opposite to the first when viewed normally. What is the real distance? Okay, so Therefore, here what is given now? Therefore, here there is a one glass slab is there now. We don't know its refractive index, we want to calculate. So, the total distance, total length of this one is how much now? 4.5 centimeter it is there now. Now, really there is a one bulb is one bubble is there no, somewhere bubble is there no, somewhere here. There is an air bubble. If you are viewing from here, from it will be seeing that it is at 2 centimeter. That means here it will be seen at 2 centimeter here now. If you are seeing from here, it is seen at 1 centimeter. Clear? So, it is seen at 1 centimeter. These are nothing but apparent distance. Apparent distance onto this. Clear? Now, he is asking what is the real distance between the first phase. Therefore, this is your first phase and second phase. No? So, therefore, this distance is asking on this one. Suppose this is your x and this distance is how much now? 4.5 minus x will be your distance. Clear? This is your real distance now. This also real distance onto for this one. Now, you can rewrite it as therefore here. So, object is there inside the water onto this one. No? We are seeing from outside means what you can write it now? Real depth by apparent depth is nothing but a refractive index. So, refractive index is nothing but a real depth by real depth is x by apparent depth is 2 centimeter. Here refractive index is equals to, therefore, real depth is nothing but a 4.5 minus x divided by 1. Clear? So, then we can calculate refractive index, anything no, you can calculate from here now. So, you can compare these two. So, then calculate for x, calculate for this one now. Both are equal. So, x by 2 is equals to 4.5 minus x. So, multiply it now, x is equals to 9 minus 2x. So, taken here now, therefore, 3x is equals to 9, therefore, x is equals to 9 by 3. So, therefore, 3 centimeter. That means, real distance here now, how much now? 3 centimeter now. Clear? So, you may calculate a refractive index also. So, refractive index is how much now? This is 3 by 2 because x value we got it as 3 centimeter. Other distance also you can write it now 4.5 minus 3. So, therefore, this other distance it will be equal to 1.5. Clear? No? Now, we want to calculate here normal shift, right. So, here there is an object is there now, here thickness is there. What will be the normal shift now? It's a very simple question now. So, therefore, light rays are coming and falling on this. Okay. You can light rays are coming and falling, right. So, what will happen now? It will bend toward the normal. It will bend toward the normal. So, then again what will happen now? Traveling from here now. So, it will bend away from the normal. These light rays are appears to be coming from here. This is your image, or this much amount of shift is taken place now, or we can call it as this is nothing but a apparent distance. Now, here this shift now we can calculate it very simple one formula. Shift is equals to thickness of the slab 1 minus 1 by n, we already calculated, you understand now. So, thickness is how much now? 15 into 1 minus 1 by refractive index is nothing but a, this is 3 and by 2. Therefore, 15 into 1 by 3, that is nothing but a 5 centimeter. This much amount of shift is taken place now. Clear? So, does it depend upon this one now? So, where we are keeping on to this, therefore, does not depend on to this, where we are keeping on to this one now. Object position does not matter on to this, and medium here and here it should be the same on to this. Clear? Actually we need to calculate, therefore what will be the A by C value. So this is the question. So now how to calculate this one now? See, very simple one. No? We'll apply the Snell's law here. No? So here this is your n1 into sin I is equals to n2 into sin R. Clear? So but what we know it now, here this side it is A, so magnitude wise you can take it, no, this is nothing but a B. So therefore tan I, it will be nothing but a by B. Clear? So what I can write it now, here this is your I, no, so this is I, tan means opposite side by adjacent side, this is nothing but a root of A square plus B square. Clear? No? So tan I is equals to A by B. So therefore sin I you can write it as, so A by root of A square plus B square. Clear? So similarly here you can write it, no, n1 is nothing but a 1.5. So into sin I is nothing but A by root of A square plus B square is equals to n2 is nothing but a 2 into B by root of A square plus B square. But what we know it now? We know it, they are unit vectors. Unit vectors means what you will get it now? Magnitude of AI cap plus BJ cap, it will be equal to 1. That is nothing but a root of A square plus B square is equals to 1. Root of C square plus D square, it will be equal to 1. Sorry, here no. This is here C square plus D square. This will be equal to 1, this will be equal to 1. So this is 3 by 2 into A, so it will be equal to 2C. Actually this is C. This is C. So 2C, so therefore A by C is equals to 4 by 3. This is your answer. Clear? Right? So the method you need to understand here now, right? If any time vectors are given, no, therefore how to solve it. So everything is related to the Snell's law only. So how we are calculating, just to try to observe it, no. So any time vectors are given, just you can solve it. Clear? Then we will go for next question. No? Yeah. So we have to calculate this apparent distance between the observer, therefore this one. So this one, what it will do, it will shift it here, this will also shift it here, this will also shift it here now. Clear? So due to this one now, somewhere it will come to here. So this is because of due to the shift of every substance onto this. Clear? So due to this one now, the shift, what you will get it now, due to this one now, total shift. Total shift, you can rewrite it as shift due to this one now, 2 into, therefore 1 minus 1 by 2 plus, therefore, sorry, not 2 into. So this total shift, you can rewrite it as shift because of due to this one, no? This is given 10 centimeter into 1 minus 1 by 2. So you know the formula, shift formula, clear? Plus due to this one, no? 12 into, therefore 1 minus 4 by 3 means 3 by 4 plus due to this one, no? So 9 into 1 minus 3 by 2 means 2 by 3. Clear? So this is 1 by 2 means 5 plus this is 1 by 4 means 3 plus this is 1 by 3 means 3. So therefore here he right 11 centimeter will be your total shift. So we don't want to calculate the shift, no, we want to calculate the apparent distance. Apparent distance means what? This distance we have to calculate it. Clear? This distance means what, how much it will be now? It is came to 11 centimeter now, right? From here to here, we know some distance. This distance is 11 centimeter now, and from here to here, what you get it now? 10. This I'll add it now. 10, 20, 32, 41. 41 centimeter. Therefore, this is your apparent distance now. Apparent distance. What you can write it now? 41 minus 11. So 41 minus 11 is nothing but a 30 centimeter. So this it will be your apparent distance between the object and your eyes. Clear? Now here, yeah. Now here we can go for an object is placed at 21 centimeter in front of a concave mirror. Now this is your concave mirror. At what distance is kept now? 21 centimeter from the concave mirror. Of radius of curvature, this radius of curvature is given how much now? 20 centimeter. A glass slab of thickness is 3 centimeter. It is kept. Refractive index is given as 1.5. So placed close to the mirror in the space between the mirror and object. Find out the position of the final image formed and the distance of near surface to the slab of the mirror is 10 centimeter. Okay. So first of all, what will happen now? This light ray, it will go like this. You already know now. This one it will go like this, right? So therefore here for this one now, this glass slab is there. Really this object is at this point now, but it does not look like that at that object now. It is looks like somewhere here onto this. So this is because of due to the shift. Clear? So how much shift it can takes place now? Shift it will be equal to, so thickness into 1 minus 1 by n. So thickness is 3 centimeter. 1 minus 1 by 3 by 2 means 2 by 3. So therefore here 3 into 1 by 3. So 1 centimeter. Therefore this shift we got it as like a 1 centimeter. Understood? Clear? That means, so really this object where it is there now? Now it is 21 centimeter means this is at 20 centimeter. Clear? This 20 centimeter. That means for this mirror, this object looks like 20 centimeter only. But radius of curvature is 20 centimeter. So 20 centimeter means the light rays are coming from here, no? It is incident perpendicular to this one, no? That means this is nothing but a center of curvature, no? Most of the students will know what they will tell now. Image is also formed at 20 centimeter. But really wrong. Why? So why? Because here this is object. So compulsory image has to form here only. That means it has incident here and coming back onto this. Then it will not come back to here because of due to this refraction. No, again it will come back to here. Again here only the image will be formed. So image position is at 21 centimeter from the mirror onto this. Most of the students they will write it as 20 centimeter. No, not. Right? Why? Because here initially one more refraction now, while coming back also one more refraction is taken place now. Therefore, where is the object is there, there only the image is created onto this, right? So this type of tricky questions, no. So most of the students will get trapped onto this. So practice this type of questions now. Clear? Now, yeah, this is just now we derived onto this. So we derived no lateral shift. What is the formula here now? Lateral shift now. Lateral shift. Therefore, here what will happen now? This it will go like this, and then afterwards it will go like this. Go like this. So therefore, d is equals to t by therefore here cos r into sine of I minus r. This is here. We derived already, so just substitute it, you can get your answer on this one. Clear? So thickness is how much now? 10 centimeter, 10. So r we don't know, we want to calculate r, therefore apply the Snell's law here now. Snell's law, 1 into sine 60 is equals to, therefore root 3 into sine r. So sine 60 is nothing but a root 3 by 2, so root 3 into sine r. It cancel out, no? 1 by 2 sine 30. So r is equals to 30 degree. So now I got it as r is equal to 30 degree. So cos 30 into sine of 60 minus 30. Clear? So therefore 10 by cos 30 is nothing but a root 3 by 2 into 2. Sine 30 is nothing but a 1 by 2. This will get cancelled out, no? 10 by root 3 centimeter. Understood? Clear? Also time taken by the light ray to cross this one, no? So what is the formula we derived onto this one now? formula we derived. What is that formula? Time taken here, no? I'll check it here. Here time taken is nothing but a thickness into n by cos r into c. Thickness into n by cos r into c. Right. So time taken it will be equal to thickness into n by cos r into c. Thickness is 10 centimeter. Clear? So answer should be in terms of meters here. 10 into 10 to the power of minus 2. Refractive index is nothing but a root 3 by cos r is nothing but a cos 30. Cos 30 is nothing but a root 3 by 2 divided by 3 into 10 to the power of 8. Clear? This root 3 cancel here, no? So therefore here what you can write it now? Therefore here 2 by 3 into 10 to the power of minus 9 seconds. This is your time. 2 by 3 into 10 to the power of minus 9 seconds, no? It will take to cross this slab onto this. Clear? Right? Now we will go for one more question, no? Right. Right. So don't confuse by seeing of all these different things, no? Find out the angle of incidence, theta we want to calculate it, no? For which the light ray just missed entering the fourth region. It should not enter. This is your one of your IIT advanced question now. This is now. So IIT advanced question, this one, no? So very simple one, no? See, it's not entering into this one now. Therefore, just miss the entering now. What will happen now? It is entering from denser medium to rarer medium. Bend away from the normal. So bend away from the normal now. Again entering into this one now. Bending away from the normal. This is a denser medium. This is a rarer medium. Like that. So just miss entering means this should be compulsory. It should go in the form of a critical angle. That's all. This is theta. This is suppose here theta 1. This also theta 1, this is theta 2, so this also theta 2. Theta 2 should make nothing but a critical angle. We will apply the Snell's law here, no? Apply the Snell's law each and every point, no? So mu naught into sin theta, it will be equal to mu naught by 2 into sin of theta 1. Clear? For this one now, this theta 1 and this theta 1 will apply, no? So mu naught by 2 into sin theta 1 is equals to mu naught by 6 into sin theta 2. This theta 2 is also same, no? Therefore mu naught by 6 into sin theta 2 is equals to mu naught by 8 into this is 90 degree sin 90. All are equal. So sin 90 all are equal means we want to calculate theta only. This one make it equal, no? So mu naught into sin of theta is equals to mu naught by 8. This mu naught cancel. So therefore here theta is equals to sin inverse of 1 by 8. So this will be your angle of incidence, no? So that it will be just and miss the entering of fourth region. Clear? So it's very simple one, no? But right, we will make complicated, right? So we'll see one more question now. Calculate the critical angle for glass air interface. Okay. If the ray of light is incident, okay, it did not give the refractive index. If the ray of light is incident on the glass surface is deviated through 15 degree when the angle of incidence is 45 degree, right? So suppose there is a glass is there now. This is one glass. Clear? So we don't know refractive index of this one now. So he said that angle of this is your incident ray. This is making an angle of 45 degree. This is your angle of incidence. So this is your refracted ray. So therefore angle of refraction we don't know, but he gave angle of deviation. What is angle of deviation now? Angle of deviation is nothing but I minus r. I is how much? No, 45 minus r. This is given as 15 degree. So r is equals to 45 minus 15, therefore 30 degree. R we got it, right? So we want to calculate the refractive index, no? So we'll apply the Snell's law here, no? Again this is your air. So therefore 1 into sin 45, it will be equal to n into sin 30. Clear? Sin 30, sin 45 is 1 by root 2. So therefore n into 1 by 2, n is equals to 2 by root 2. That means nothing but a refractive index is root 2. Clear? But is asking critical angle, no? So sin C is equals to 1 by n, 1 by root 2. So therefore sin 45. So critical angle, it will be equal to 45 degree. Clear? So very simple concepts, no? You can solve it. Here, this also one of your JEE main question, no? So I think it is visible, right? Now a transparent solid is there. This is one solid rod, a solid cylindrical rod of refractive index. He gave refractive index, no? 2 by root 3 is surrounded by the air. Light ray is incident at the midpoint onto this one, no? Right. So find the angle of incidence which light ray grazes along the wall of the rod, right? So this understanding is very important. Grazes along the wall of the rod. That means this light ray will go like this, then afterwards it will grazes like this. So for this one, no, theta we have to calculate. He gave refractive index, no? This theta we want to calculate, compulsory, this should be compulsory critical angle. You understand, no? So this is like this. So we can, this is R, sorry, this is your R. Now we will calculate first of all critical angle, no? This critical angle, no? A reverse will come. So therefore here n is given, because n is given, no? So sin C is equals to 1 by n. So n value is nothing but 2 by root 3. 1 by, this is root 3 into 2, sorry, 2 by root 3 means this is 2 by root 3, root 3 by 2. So that means sin 60. Therefore critical angle, it will be equal to 60 degree. Now I got this angle is 60 degree, this angle is 60 degree, this angle we want to calculate. That means this is 90, this R should be equal to 30 degree. Now I got it as angle R is equals to 30 degree. So again apply the Snell's law here, no? What will be the Snell's law? 1 into sin theta, it will be equal to, n is nothing but 2 by root 3 into sin 30. Clear? So sin theta is equals to 2 by root 3 into 1 by 2, get cancel out, no? Theta is equals to sin inverse of 1 by root 3. So theta sin inverse of 1 by root 3. So fourth option will be your correct answer on this. Clear? Right? Now we will go for one more question, no? Right. This figure shows the light pipe made up of a glass fiber of refractive index is root 2. Core cladding is given now, right? Okay. What is the maximum angle of incidence ray? So with the axis of the pipe with total internal reflection takes place. Yeah. So maximum angle, I already gave the formula, that is nothing but a sin I is equals to root of n2 square minus n1 square. n2 is nothing but a root 2 whole square minus root 3 by 2 whole square. Clear? So this is nothing but a 2 minus 3 by 2. So that is nothing but a root 4 minus 1, 1 by 2. So therefore here, so it can be written as 1 by root 2, therefore sin 45. So I should be equal to 45 degree. Right. So mostly right, can expect these type of questions, no? Right. Right. So we'll draw the questions here itself, I think. Okay. So here there is an object is there in front of a right angled prism, no? Therefore two positions are there. So the prism is made up of crown glass with a critical angle is 41 degree. Critical angle. Trace the path of the rays from the PQ and as shown in this one, right? So we have to draw the path of the rays, no? So here this light rays, no, this tip of this one, no, it will go like this. So what will be the angle of incidence here now? Definitely, so it will be 45 degree. Why? So because here 90 degree, this is 45, means compulsory this also 45. So this also 45. Therefore angle of incidence is 45 degree, means here it will be critical angle is 41 degree. So 41 degree. So angle of incidence is greater than the critical angle. So undergo total internal reflection, no? Yes, sir? So therefore here what will happen now? This it will go like this. So it will go like this. Also it will go like this. Then again here also it is also 45. Then it will go toward this side. Then go toward this side. This is your Q and this is your P. In this way the image it will be formed here. Clear? Now we will see. So one more here, no? Therefore here also it will go. This is 45, means this also 45. Again total internal reflection will take place, no? Right? So therefore it will go out onto this one, no? Clear? So normal incidence here, normal incidence, no? Therefore here it will go like this, go like this. This side it is P. So therefore here this is P, this is Q. In this way the images. So even this prism, no, total internal reflection it will utilize to invert the image. Therefore if it is like this is there, sometimes the object should be in this way like that, no? Therefore you can make it like a inverted image, no, by using total internal reflection in the mirrors, in the prisms. So this is one interesting question, no, most important, no? Right. So what should be the value of theta, this theta, such that light ray performs total internal reflection at the surface of this AC. So this theta should be there, we want to calculate. Here again normal incidence, now normal incidence means what? Angle of incidence is 0 here now. This directly it will coming on to this. Clear? So that means here this is your normal here, no? So what is the normal at this point now? Here, right? So therefore here it will be this one, no? Clear? So that means what should be the angle of incidence here now? This is 90. So this is theta, this is 90 minus theta. Clear? So therefore this also it will be 90. So this should be compulsory the theta. Clear? This is theta. This it should be equal to 90 minus theta. Understood? So 90 minus theta. So therefore now it should go like this, so that total internal reflection will take place on this. Therefore here we can apply the Snell's law at this point now. Therefore here mu, so therefore it is 3 by 2 into sine of 90 minus theta, it will be equal to, therefore mu is nothing but 6 by 5 into sine 90. Clear? So therefore what you can write it now, this is 2, so sine, therefore you can write it as cos theta, it will be equal to 4 by 5 into 1. Therefore here theta is equals to cos inverse of 4 by 5. Cos inverse of 4 by 5 we can rewrite it as, here this is your theta, this is 3, 4 and 5, this should be is nothing but a 37 degree. Therefore cos 37 is nothing but a 4 by 5, theta is equals to, so therefore 37 degree. So, therefore, here this should be compulsory, it is about 37 degree. Clear? You understand? No? Right? Right. Now, we will go for next question. No? Right, very simple one. No? Suppose here a light ray is incident on a glass and water interface at an angle of I, shown it like that. It is emerges finally on the surface of the water. Right. So, therefore, we want to calculate what will be the value of mu g. Therefore, refractive index of this mu g we want to calculate. This is here refractive index of the glass. Clear? So, again every time you have to apply the this Snell's law only. Here you can apply the Snell's law. So, I, so travelling from, therefore mu g into sin I, it will be equal to entering into this one. No? Therefore, so 4 by 3 into sin r. So, here also 4 by 3 into sin r is equals to 1 into sin 90. So, all are equal onto this one. No? Therefore, mu g can be written as this, and this you can make it equal. No? 1 by sin I will be your answer. Very simple one. No? Clear? But looks like it is difficult, right? So, very simple. We will see one question. No? Right. What will be the minimum angle of incidence such that total internal reflection occurs both the surface? Right. Actually, here complete diagram was not there. No. Here. Therefore, here there is a light rays incident. Right. So, we want to calculate it now. Therefore, this is here I. So, we want to calculate it. So, it will undergo like a total internal reflection not only here, so it will be also here. I think you are able to see it. Clear? So, also it will undergo like a total internal reflection at this point. Clear? So, now first of all let us apply here no at this point. So, minimum first one no, first reflection no, we can write no, first one no. So, light rays travelling from refractive index is 2 into sin I, it is entering into this one now root 2 into sin r. Clear? Right? So, therefore, here sin r means minimum we can write it as not the sin r. So, here root 2 then it will go like a total internal reflection. Therefore, it is sin 90. We can go for critical angle. Sin I it will be equal to root 2 by 2. Therefore, 1 by root 2 sin 45. Therefore, angle of incidence it will be equal to 45 degree. So, to undergo total internal reflection at this point no, angle of incidence should be more than 45 degree. That means, first situation should be equal to compulsory more than 45 degree. So, let us do the second situation now here. Second situation now here, second reflection at this point. So, light ray is travelling from denser to denser is what 2 into sin I is equals to root 3 into sin 90. Right. So, sin, okay, this is your next one, right. So, sin I dash, therefore, sin I dash is equals to root 3 by 2, therefore, sin 60. So, I dash should be greater than 60 degree. That means, here most of the students know, they will think that 45 degree will be your answer. No. Why? Because here 45 degree is there. More than 45 degree everything it will be there. Even if it is a 45 degree is there, here it will not undergoing a total internal reflection on this one. Why? Because here requires 60 degree more than this one. But here also 60 degree also is there, because it should be more than 45 degree. So, compulsory both the surfaces if it should undergo total internal reflection, angle of incidence should be greater than 60 degree. Then only the then only the total internal reflection will take place at this point and at this point onto this. Clear? So, answer will be greater than 60, not 45 degree. Clear? Like this confusion will be there. So, you can solve it very easily. Clear? Now, let us see one more question now. So, here also similarly like a total internal reflection. No? Right. Light is incident normally. This is normal incidence. Normal incidence means what? Therefore, here it will be 90 degree, angle of incidence is 0, right? Normal incidence, right? So, a liquid of refractive index is there. This is your refractive index is mu is refractive index. Is placed on the surface of the face of AC of the prism, and the prism is made up of a glass of refractive index. This refractive index is 3/2. Mu value we want to calculate, for which it will undergo like a total internal reflection now. So, total internal reflection, first we will go for critical angle here now. This is 90. So, compulsory this should be 30. So, this should be compulsory 60 now. Clear? So, that is why the students will face difficult now, because they are slightly very lagging on the calculating the angles onto this, right. So, to understand the ray optics, no, you should be very thorough in the geometry onto this, right, especially measuring the angles. Clear? So, therefore, here it is sin 60, therefore, here it is travelling from here, no, 3/2 into sin 60, it will be entering into this medium mu into sin 90, minimum critical angle, first of all you should know it. Clear? So, therefore, 3/2 into root 3/2 is equals to mu value should be equal to 3 root 3/4. This should be your minimum refractive index onto this. Clear? So, should be what? So, should be lower than or equal to this. This should be our refractive index of this liquid onto this. Clear? So, because this should be denser medium, this should be rarer medium. Clear? Like that. We will see some more questions now. Yeah, okay. I think the time, right. So, maybe with this video may be length, I think we covered a lot of questions onto this one. So, still if any questions are there, so I will collect it and I will do like some numerical questions related to this refraction onto this. Clear? So, some more questions will be there like calculating the speed and calculating the optical path length, right, and relation between speed and critical angles onto this one. So, in the next video, so we will do that questions also. In the next concept, that is prism, we will discuss the remaining problems also, right. So, thank you for watching. Please subscribe to my channel and you can learn physics very easily.